Well, thank you for joining me. I'd like to run through a few examples that I am recording because I can't physically or virtually be there live during the lesson. So this recording will be a substitute cover for my absence. I apologize for not being able to make it to this lesson. But we are required here in exercise 10I. If you go to posts of classroom assignments, you will see which particular numbers you can work on. But I'd like to look at a few examples. And for each example, I want you to understand the net shape of the solid once it's folded, like it's cut open and it's folded out. And what does it look like? Because that will show all the sides. So if you cut this open, you will see that there's a square, that's the base, and the square is an 8 by 8 because it's a square. It's got like little dashes to show that it's a square. Now this side here will fold out, and it will fold out to be a triangle, which is flat, and you see that the triangle has an altitude of 6. So from the tip to the middle of that side, or at 90 degrees, that right angle, that is a 6 length, 6 centimeters. And then you will see that all triangles will fold out, and there will be 4 of them, and they're all identical. So they all have this little length of 6. So when they fold out, this is a rough diagram, but you see that they will all have an altitude from the tip to the base of 6 centimeters. So we want the surface area of this square-based pyramid. So we've got the area of the base plus 4 area of triangles. So the area of the base is going to be side squared. It's a square. And each triangle is half base times perpendicular height. So the side of a square is 8, so it's 8 squared. And we've got 4 triangles, half base, each base is 8, the perpendicular height is 6. And so you've got 24 times 4, so you've got 96. And 8 squared is 64. So the total area is 160 square centimeters. Excuse me. All right, so that is the total area. I'll put area T for total. And so it's just one way to say that. But when you look at your textbook, I believe this example may be in your textbook. But if I go into, I think which textbook is it in? I think it's this one. I've just looked at example 24, and we've got a little bit more information, and you can see that the area is 160 square centimeters. So the surface area of the square pyramid is 160 square centimeters. All right, let's look at a second question. So I don't want to take up too much of your time so that you can practice this. The second example is a cylinder. And same thing, if you cut the wall of the cylinder and fold it out, you have a rectangle where the length of that rectangle is like the circumference of that circle, which is 2 pi r. So that's how long it is, and the perpendicular height, that's this. Now when you've got this circle here, there will be a circle attached to both of those ends that fold in, and these radiuses are 8.5. That's the radius of each of those circles. Please make sure you know if it's a solid cylinder, but it just says a cylinder, so we will include both bases. And we want 1 decimal point. Let's put a square there. And this height is 15.7, the distance from one end to the other. and the radius we already know is 8.5 centimeters. So let's look at the area of, say, the curved wall and lots of area of the bases, and that will be our total surface area. The wall is a rectangle, so it's length times width. So that's 2 pi r times h. And 2 circles, and so that's 2 pi r squares. We substitute 2 pi, the radius is 8.5, the height is 15.7, plus, now 2 circles, pi, times the radius squared. I think here we need a calculator, so let's just make a note of that so I can put these numbers in the calculator. Let's go to a calculator. Two pi, 8.5, 15.7. So 2 times pi times 8.5 times 15.7. Okay, that's the area of the wall. So 8, I wonder if I can copy and paste that. 838 49107. 9107 ... Now 2 pi 8's 2 pi. I'm just going to continue now. I'm going to plus 2 times pi times radius 8.5 squared equals. Now that's the total sum. 1292 4512. 1292 4512. I actually didn't get that number there. Now, one decimal place, so approximately 1,292.5 square centimeters, because it's square centimeters, 1 decimal place. So the total area is approximately 1,292.5 square centimeters. Let's just check that answer. 1,292.5. And so this is the second example here, and they've got 1,292.5 square centimeters. Notice in the answer they've written 1292.451 ... All right, so that's what I've done. Look at the formula. Pi r squared, there is a formula for cylinders, and if you want to put those in your summary notes, you will find that there's a formula for cylinder surface area is 2 pi r squared, so that's 2 circles, and then the wall, 2 pi r times h. You can simplify that to 2 pi r times r plus h if you want. There's a cylinder of a sphere, 4 pi r squared, so the sphere is the same as 4 circles. Then you've got this surface area of a cone. You've got the base, which is pi r squared, and then this curved part is pi times radius times slant height, s, and that's the slant from the top all the way down, not the perpendicular height. Careful with that. It's just the slant height. So let's have a look at one more example, and that will finish. You can carry on and try exercise those questions. So this is a sphere. I'm not going to do a net of this. I'm just going to go total surface area straight up is the same as 4 pi r squared because it's a sphere. The radius is 5, so it's 4. What is it? 2 decimal places. You know what I forgot to do in the previous one? I forgot to tick that when I did it to 1 decimal place. 4 times pi times 5 squared. So let's go to our calculator. 4 pi 5 squared. 4 times pi times 5 squared equals 314.1592. 314.1592 dot dot dot, and we want 2 decimal places, so that is 314.16, and it's cubic, not cubic square, millimeters, because it's millimeters, and that's 2 decimal places. Now we can tick that box because we've done it. 314.16 square millimeters. So let's go to this third example, and it was a sphere, and it's 314.16 square millimeters, correct to 2 decimal places. So you can work on those questions that I have posted on the homework in exercise 10I. I hope this has helped. Have a happy day.